Hello, everybody. We are going to be looking at our 4.2 notes, which are proving that triangles are similar by side, 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 angle, side, and technically it's angle, angle, but I like to throw the third angle in there. So side, 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 angle, side, and angle, angle, angle. Yay. All right. So there are a couple things that we need to know in order to prove that triangles are similar. So these things look a lot like what we did when we were proving that triangles are congruent, but we're no longer proving congruency. Now we are talking about similarity. Remember that with congruency, angle, angle, angle was not a way to prove congruency. We couldn't use that. We can use angle, angle, in parentheses angle, to prove similarity though, okay? And then just like with triangles, you could use side, 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 and side, angle, side to prove congruency. You can use side, 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 and side, angle, side to prove similarity. So here we go, let's talk about it. It says, if two angles of one triangle are congruent to two angles of a second triangle, then the triangles are similar. And that kind of makes sense, right? So here's a visual for you. We only need two of the three angles because if we know two angles, then we automatically know the third angle. So here we have one triangle, another one. This angle is 100. This angle is 100. I know that this angle is 50. And this angle is 50. If I see this, the angles don't have to be in the same place. If I see this, then I should be able to say automatically, yes, these triangles are similar by angle, angle. A lot of students just like to throw the third angle in there, and I'm totally fine with you doing that. So if you want to say that these two triangles are similar by angle, 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 by all means. Now, we don't know what that third angle is, but we know that since the other two angles in the triangles are the same, that third angle is going to be the same no matter what, because both triangles still have to add up those interior angles to equal 180. So that's what that would look like. Okay, next, side, side, side. Says if all three corresponding sides of two triangles have the same ratio, then the triangles are similar. So what does that mean? Let's talk about it because this one gets a little bit tricky. Okay, and I'm just making up, no, I don't like these numbers. I'm just going to make up numbers, okay? Just bear with me. Okay. Okay, we're going to have triangles that look like this. We have no angle information. We only have sides. When this happens, what we have to do is we have to figure out what sides correspond to each other. And we do this by looking at the smallest sides and pairing them up, the largest sides and pairing them up, and then the middle length sides and pairing them up. So when you look at the triangle on the left, the smallest side is 4. Now I need to look at the triangle on the right and pick its smallest side. And that smallest side will be 8. So I know that those are going to go together. Then I'm going to go for the medium length. In the next triangle, or in the first triangle, it's 5. In the second triangle, it's 10. And then we've got 6, the largest side, and 12, the largest side. And what we have to do is we have to ensure that they have the same ratio. So here's what we do. Everything over here is going to go on top. Everything over here is going to go on bottom. So we've got 4 over 8, we've got 5 over 10, and we've got 6 over 12. Sorry if you hear weird noises in the background. Okay, I have to simplify these ratios to ensure that they are the same. 4 over 8 simplifies to 1/2. What about 5 over 10? That also simplifies to 1/2. And then what about 6 over 12? Well, that will also simplify to 1/2. As long as all three of these have the same ratio, which they do, then we can say that these two triangles are similar by side, side, side. Okay? Lastly, we have our beautiful side angle side, which says that if two corresponding sides of two triangles have the same ratio and the angle between those sides are congruent, then the triangles are similar. So let's look at it. We've got two triangles. I'm just going to make them orient the same way just to make life easier for us. 4, 8. I'll do 10 and 20, and then I'll say that this angle is 40 and this angle is 40. Okay? And I'm telling you right now that the way that these triangles are oriented is the right way. And we can also look at those sides again. 4 is the smallest, 8 is the smallest, 10 is the biggest, 20 is the biggest, and then their angle that's contained in between them are congruent. We have to check our ratios, guys. We have to check the ratios. Anytime you have a side, you must check the ratios. There are no ratios to check here in angle, angle, angle because I don't have any sides. But if you ever have a side, you must check those ratios. So we are going to do 4 over 8, and we are going to do 10 over 20. And I picked easy ones so that I could just do this off the top of my head. So 4/8 simplifies to 1/2, and then 10/20 also simplifies to 1/2. Those are the same, and the angle in between are the same. Therefore, they are going to be similar by side, angle, side. Okay, so anytime you have a side, you better check those ratios. We are going to talk about angle-angle similarity. First thing we need to do is mark any angles that are congruent, and then if at least 2 angles are congruent, you have angle-angle similarity. You can say that triangles are similar by angle-angle, or you can throw a third angle in there and make it angle-angle-angle, which is my favorite thing to say in the world. It's up to you. All right, so taking a look here, I clearly have 48 and 48. When I look at the other 2 angles, they do not match. However, I should check the third blank angle, because for all I know, in that first triangle, that blank angle is 70, and then in my second triangle, that blank angle is 62. So I'm going to look at my first triangle, and I'm going to do 180 minus 48 minus 62, and lo and behold, we get that this angle is 70, which automatically corresponds to this angle over here. And then if you really have a hard time with trust issues, you can do 180 minus 70 minus 48, and you can see that this other angle down here is 62 degrees. Should not have done that. I've already done green. What about blue? Do you look nice? You're okay. All right, so are these 2 triangles similar? You would say yes, they are, and you would say by angle, angle, angle. We already know, because it's in the angle, angle, angle section, but yes, okay. Looking over here, I don't have any like numerical values for my angles, but what I do have is I have parallel sides. And anytime that you've got parallel sides, remember that you've got some nice angle pairs. So I know that B and E are congruent because they're alternate interior angles. I know that D and A are congruent because those are alternate interior angles. And then I know that these 2 angles here are going to be congruent because they're vertical angles. So are at least 2 of the 3 angles congruent? Yes, they are. Therefore, this is similar, and you would say by angle, angle, angle. And then if it needed a similarity statement, you would do that. But that's how you check for similarity using angle, angle, angle. Those are just 2 different examples. Next, we're going to do side, side, side similarity, and it tells you the exact same thing I told you up above. You are supposed to be matching the shortest side of one triangle to the shortest side of the other, and then the middle with the middle, and the largest with the largest. And then you must check to ensure that the ratio of the side lengths are the same for all 3 sides. Just because they work for 2 sides doesn't mean that third side's going to work. You have to check it. So we're going to take a look at this example here. And what we need to do is we need to pair up the biggest side, the middle side, and the smallest side. So I'm going to start with the smallest side, 14. And then over here, the smallest side is 21. So those are going to go together. My middle side will be 16. Over here, my middle side is 24. And then over here, my largest side is 18. And over here, my largest side is 27. Just like with anything else that I'm doing with ratios, I need to choose stuff that goes on top and stuff that goes on bottom. And then I'm going to set up my ratios. So you've got 16 over 24. I've got to simplify that. Then we're going to do 14 over 21. I'm going to simplify that. And then I got to do 18 over 27. I'm going to simplify that. And I don't have like an actual calculator on me, so let's see how this works. Okay, 16 over 24. If I could take out an 8, that would be 2. I can take up something bigger. Huh? Y'all, my brain's not working. Hold on. Oh, yeah, you take out an 8, you're left with 2 and then a 3. 2/3. Yay. All right, let's look at 14 and 21. We can take out a 7. You are left with 2/3. Yay. Don't stop there. Keep going. You've got to check the last ratio just to make sure. 18 and 27, we take out a 9, and we are left with 2 and a 3. Okay, so are these triangles similar? Yes, they're similar by side, side, side. And then what is the ratio that we got? The ratio that we got was 2/3. So that is how we ensure that these triangles are similar. Okay, you've got to check all 3 sides, their ratios. Scoochie on over here. All right, smallest side is 8. Smallest side is 4. Hey, this looks familiar. I've got middle side is 10. Middle side is 5. And then over here, we got us a 12 and we got us a 6. Everything over here is going to go on top. Everything over here is going to go on bottom. So here we go. 12 divided by 6. 10 divided by 5. 8 divided by 4. This is 2. This is 2. This is 2. Are they similar? Yes, they're similar by side, side, side. And we would say that our ratio is 2 over 1, or just 2 is fine as well. Okay. Next, we're going to check side angle side similarity. So this one gets a little bit weird. Okay. It says that we need to mark the angles that are congruent. Nasty. All right. Then we need to make ratios using the matching sides, and then we need to solve the proportions. So here we go. Take a look at this example here. I have a parallel side and a parallel side. So anytime I've got those parallel sides, I am looking for angle pairs. Those angles go together. These angles go together. And these angles go together. So I already know that they are similar by angle, 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 but I have to use that information to help me with finding missing sides. Because unlike this example up here, I don't have all of the sides of all of my triangles, okay? So now that I'm here, I've got to figure out which sides correspond to each other. And I have to look at their location on the sides of my triangle. So here I've got a 15. Notice that 15 is in between the single marker and the vertical angle. So in my small triangle, which one of those sides is between the single angle marker and the vertical angle? Well, that's going to be Y. I just put a cough drop in my mouth, so if you hear any weird noises, that's why. 10 and 6 are going to go together. Those are on the parallel sides, and they're between the single and the double angle marker. And then lastly, 20 is between the double angle marker and the vertical angle, and X is also between the double angle marker and the vertical angle. So that's what we're looking for. Okay, so now we know it goes together. Now, I know that this is side angle side similarity. I already know that I've got the other angles, but if you look, well, actually, never mind. I'm getting ahead of myself. Okay. Everything over here is going to go on top. Everything over here is going to go on bottom. I'm looking for the two sides that have a numerical value. So I've got 10 over 6. And I've got 10 over 6. X and Y are both on the triangles that are supposed to be information on the bottom. 15 corresponds with Y. 20 corresponds with X. I know I sound so disgusting. I am so sorry. Interesting. This one's weird. Okay, so 20 times 6 is 120. Divided by 10 is 12. So X is 12. And then I'll do 15 times 6 divided by 10 is 9. What is the ratio? Well, if I look at 10 over 6, that simplifies to 5 over 4. So my ratio is 5 over 4. And then remember, I just found that X was 12. So I could do 20 over 12. When I take out a 4, I'm left with 5 and 3. Yeah. Y'all. Brain is not braining today. There we go. 10 over 6 again is 5/3. And now that I found out what Y was, that's just 15 over 9. You take out a 3, you are left with 5/3 again. So no matter what you're looking at now, your ratio is 5/3. Are they similar? Yes, they are. Okay. And then I have example 6. You can see where your angles are congruent. I also have these vertical angles. So I know that these are similar by angle, angle. So I can use my, the fact that I know that they're similar by angle, angle to set up my proportions. 21 is going to go with 18 because they are both in between the single and the vertical. Single and the vertical. All right. X and 24 go together. And then 12 and Y go together. Top, bottom. We've got 21 and 18 go together. I'm making a video. And then we've got 21, and 18. All right. X is on the triangle where everything's supposed to be on top. That goes with 24. 21 over 18. My Y is on the bottom, and that goes with 12. 24 times 21 divided by 18 gets me 28. So X is 28. Y is 12 times 18 divided by 21. Wah! Really? Hold on. I think that's right. I think that this is just gross. Okay. 12 times 18 divided by 21. Yeah. Okay. I don't have a calculator that can turn this back into a fraction, so just for the sake of this video, it's 10.28. But you do need to actually change it back to a fraction. I don't have a calculator. Our ratios, we have to look here. 21 over 18. You can take a 3, and you are left with 7 over 6. If I plugged X back in, that's 28 over 24. I need to take out a 4. 7 over 6. Ooh, this Y is going to be funky. I'm not going to check Y because I can't. But your ratio is going to be 7 over 6. And that's how you would use your side angle side similarity. But really, we use angle to help us on that. So I need... Now we're going to move down to a couple of examples that, you know, can come from really anywhere in the... within side, angle, or angle. Whenever you look at this example here, I do not have letters that represent these different parts of the triangles. And so I'm going to have to figure out, because I don't have a similarity statement, how these triangles are similar. So if you look, we do have parallel lines, and remember that parallel lines give us angle pairs. So whenever you have an example like this, you're actually going to end up with triangles that are similar by angle, and unless something weird is, you know, shown in the triangles, they're just going to be like one triangle within another triangle. So I told y'all last time that anytime that you have a triangle within a triangle, to redraw them as two separate triangles. And by the way, the triangles share the top of the tops of themselves there. Okay, my small triangle is X, Y, and 6. My large triangle is going to be 35 on bottom. The whole side over here is going to be X plus 18. And then the whole side over here will be a total of 30. Since we knew we had sides that were parallel and we could come up with our corresponding angles, we already know how these triangles are oriented. So I know that X is going to go along with X plus 18. 6 is going to correspond with 30. And then Y is going to correspond with 35. I do have my 6 and my 30. So little triangle will be on top, big triangle will be on bottom. I have 6 over 30 equals, and then again 6 over 30 equals. X is going to be on top, X plus 18 will be on bottom, and then Y will be on top, and 35 will be on bottom. I'm actually going to take care of the Y's first, just because I don't have to do more than just multiply and divide, and I get 7. So Y will be 7, and then I'm going to have to cross multiply over here. So this will be 6 times X plus 18, and then that's going to equal 30X. So this is 6X plus 6 times 18 gives me 108, and that's going to equal 30X. I will subtract 6X on both sides, and I get, I'm running out of room, 108 equals 24X, and then we're going to divide both sides by 24, and I get that X is 4.5. So the ratio that I found is, remember, it's 6 over 30, and that's going to simplify to 1/5. Okay. Okay, let's take a look at number 8. So when you look at example 8, you actually are only given like just a couple of pieces of information. You're given an angle and two sides. So we have to look to see if we have side angle, or side angle side. Side angle doesn't prove similarity either. We are looking specifically for side angle side. And if you look at these two triangles here, this angle would have to be here in order for us to be able to use side angle side. So unfortunately for us, we cannot say that these triangles are similar, and then there's not going to be a ratio. Last problem says a basketball player who is 2 meters tall casts a 1.6 meter shadow. At the same time, a flagpole casts a 4.4 meter shadow. How tall is the flagpole? So I'm going to like draw a picture for you. Imagine, here's the sun, beautiful, beautiful sun, okay? Shadows are cast because something interrupts the flow of light from the source, right? So when you cast a shadow on the ground outside, that's because you are blocking the sun's rays at your body, and so the sun's rays can't pass through your body onto the ground, so a shadow is cast. So this is essentially what's happening. We have our beautiful basketball player. We know our basketball player is 2 meters tall, and our basketball player casts a 1.6 meter shadow, right? The shadow's on the ground. When this happens, what ends up being created is actually this really nice little right triangle. Okay, so right now, this is what we have. I'm going to redraw it over here. Here's 1.6, here's 2, here's our right angle. It says at the same time, a flagpole. So here's my flagpole. My flagpole is too long. My flagpole goes to about there. Okay, a flagpole, there's my flag, casts a 4.4 meter shadow. So this flagpole is casting a 4.4 meter shadow. Actually, no. I do this every time I draw this picture. It doesn't necessarily block the person. I just know that the flagpole casts a shadow, and the shadow is 4.4 meters. But the sun is still at the same like level in the sky. It's still at the same angle at the sky. So because of that, this is called the angle of elevation. The angle of elevation is going to be the same because the sun is in the same spot in the sky. So it's not going to affect the angle that the sun's rays are being cast upon the ground or cast upon the earth or whatever, okay? So here we have this angle, and then we go wee, and then here's my flagpole that's casting a 4.4 meter shadow, and what we're being asked to do is find the height of the flagpole, okay? So we have two triangles that are similar by angle, so we know that we can set up a proportion. And if you look, we really have side angle side here. So we know that 2 and x are going to go together, and then 1.6 and 4.4 are going to go together. So everything over here will be on top, everything over here will be on bottom. We have 2 over x equals 1.6 over 4.4. I'm going to go ahead and plug this into my calculator. So 4.4 times 2 divided by 1.6, and that gets me, hold on, I don't remember that being the answer last time. It probably is. I just need to check my work again because I'm silly. Yeah, it's 5.5, okay? So the flagpole is going to be 5.5 meters tall. Please don't forget your units. And there we go. So that is how we use triangle similarity to set up proportions and solve for missing sides of our triangles. And that is all I have for you. If you have any questions, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye.